Hello, and thank you for taking the time to view this on-demand webinar session, Harnessing the Cloud to Boost Digital Design, Increase Operational Efficiency and Engineering Productivity. This webinar was produced by Aberdeen Strategy and Research and is brought to you by Oracle. Joining us today are Sarah Gaffney, Senior Analyst, Research Data and Operations at Aberdeen, and Rick Titsworth, North American Strategic Pursuits Director, Manufacturing Industry at Oracle. Now I'll hand it to Sarah to get started.
Hi, everyone. I want to thank you all for tuning into the presentation today. My name is Sarah Gaffney, and I'm a senior analyst from Aberdeen covering the manufacturing and product development space. I also want to thank my co-speaker, Rick Titsworth from the Oracle side, for being a part of the conversation today. He and I will be discussing how manufacturing and engineering teams can utilize cloud-based digital design platforms to increase operational efficiency and engineering productivity. Rick, I'm excited to speak with you and our audience about some of the findings from our latest manufacturing survey and discuss the operational day-to-day advantages of digital design in the cloud. The data that I'll be pulling from for this discussion comes from a survey we fielded last year with 262 leaders in manufacturing and engineering roles to investigate the top challenges, investments, and goals for organizations in this space. We also recently partnered with Oracle to write a white paper around driving game-changing efficiencies with cloud-based digital product design. And in this webinar, we'll dive deeper into the data highlighted in that white paper and how engineering and product development teams specifically can derive value from a cloud-based infrastructure for engineering solutions. A short agenda to guide the conversation. We'll first touch on what cloud-based digital design is and why it's top of mind for engineering teams today. Then we'll dive into the operational advantages for public cloud users from Aberdeen's data, including productivity and manufacturability, process optimization, and the three metrics that everybody cares about: speed, quality, and cost. And we'll end with a summary and some key takeaways. Starting off with an introduction to cloud-based digital design, digital transformation is happening in all areas of the business, and manufacturing and engineering teams are seeing an acceleration in digital transformation efforts with the rapid innovation of new technologies and processes. They need to keep up with their competitors, and Aberdeen research shows that a contributor to how they're doing that is with the cloud. Our research shows that only 19% of manufacturers currently deploy their engineering solutions exclusively on-premise, and that leaves the other 89% deploying their solutions in some form of cloud infrastructure. When we refer to cloud-based digital design, we're talking about leveraging the cloud to house your engineering applications like CAD, virtual prototyping, and simulation. There's a myriad of reasons why companies choose a cloud environment, which we'll get into, but it's important to note that cloud solutions are the number one most common technology enabler that manufacturers are currently investing in. Rick, I'll turn it over to you here. Can you explain how the cloud acts as a base for digital transformation and how it can help organizations start their transformation efforts off strong so they can build up additional solutions and processes to adopt an efficient, agile product development approach?
Sure. Thanks, Sarah, for the intro and the lead in. We find that a lot of our customers have perhaps moved to the cloud in other aspects of their business, sometimes even before engineering. And primarily customers initiate those moves in the interest of cost and flexibility. The same applies to engineering and product digital design, with the added benefit usually of scale and performance. It's very traditional versus on-prem IT infrastructures and the cloud for customers to need to be making trade-offs between sizing their on-prem infrastructure for peak workloads and then suffering the cost advantages of having some of that be idle at other times, or sizing their on-prem architectures for average or nominal workloads, and then in the engineering case have product development teams need to sometimes wait in the queue or not be able to run an analysis at the degree of granularity that they might optimally like because of constraints for IT infrastructures. And that's one of the key advantages that goes away with folks moving to the cloud, where one, you have almost limitless performance and scalability available when needed, and otherwise you can scale back down during nominal times and not suffer the cost or the capital investment of having idle infrastructures, as well as reduced IT operational cost for things that are just automated in the cloud. But as we'll talk to in this presentation, there are other benefits that really become apparent to folks in the cloud. In fact, that some of our customers really double down on as well. And that is engineering does not operate on its own independent island, typically from the rest of the organization. And so benefits around integration and innovation with the rest of the organization, be it the shop floor, manufacturing, field service, customer feedback, future marketing plans. There's a raft of opportunities around sharing data with the rest of the organization that's easier in the cloud than typically on-prem, where we had different systems and different silos. And then as well, once folks have engineering people have access to all of that data, I can now do richer data analysis, not just of the product and the engineering, but what's the impact to the business or the impact to end user customer experiences of potential changes or cost implications with suppliers and so on. So we'll talk more about data and analytics in the cloud as well as we go forward.
Thanks, Rick. Infrastructure, cost, scale, and performance are absolutely critical for engineering teams. So let's dig deeper into the operational reasons why manufacturers might decide to migrate their engineering applications to the cloud, starting with the ability to leverage capabilities available in the cloud, such as high-performance computing, to increase their speed to market. For HPC, for anyone who's not familiar, involves aggregating computing power so you're able to run more calculations faster without putting as much strain on the processing system. HPC is more efficient in the cloud because of the availability of flexible storage, and it allows engineering teams to disperse workloads for complex simulations. If you're running hundreds, if not thousands of iterations with different variables in your models, it takes a lot of computing power, and it would take a long time to receive results if the system is slower. The data we're showing here demonstrates that manufacturers deploying engineering solutions in a public cloud environment, which is the purple bars, are more likely to optimize their engineering processes than hybrid or on-premise users, which are grouped together here in the gray bars as non-users. With HPC, public cloud users can analyze, process, product, and compliance data faster, allowing them to view quality assurance results and make decisions about parts and functionality to boost quality in the verification and testing stages. They can also continuously update their processes to figure out what's working and what's not with AI, and then implement best practices to keep moving forward. Rick, I'd love your take on whether this data aligns with how you at Oracle view the role of HPC in engineering and in the wider organization.
Sure. Yeah. There are a whole number of use cases that customers are using high performance compute in the cloud to help solve from an engineering standpoint. So those might include, as you alluded to, computational fluid dynamics. It can be complex structural analysis, heat transfer, noise and vibration, electromagnetic fields, crash analysis, and so on. And in fact, being able to leverage the performance and the scalability of cloud-based computing for their workloads can allow jobs to finish more quickly. But probably more importantly than that, it allows customers to do a more complete analysis, whether that's a finer model mesh, whether that's a broader variety of environmental conditions, whether that's more iterations on various design opportunities or options. Those all become benefits of cloud, and being able to do that broader analysis and or in less time for time to the market, of course, is a huge advantage. One of the interesting kind of newer areas that we start to see customers doing as well, as depicted by this slide, is what we call multi-physics or multidisciplinary optimization. So traditionally, why a bunch of those engineering analysis may have been done independently. And then design options or design alternatives evaluated against the independent designs. We now find folks actually kind of trying to optimize across all of the various physics/physical constraints and trade-offs that they might have to get a fully optimized final design. So huge advantage not only in cost and time, but in the nature of the final engineering design as well. Also, from a high performance compute standpoint, not just in traditional product design, but we find customers availing themselves for high performance compute for advanced end user or product simulation itself. So, for example, in the automotive industry, where autonomous driving is driving, no pun intended, a bunch of high performance compute usage, that also applies to other industries where you have autonomous vehicle behavior, autonomous movement, robotic action. And the issue there is to try and train the AI and machine learning models that are driving all of that. It literally takes millions or billions of simulation iterations. In this case, you might say billions of driving miles. And in trying to do that in the physical world is very expensive and very time consuming. If you're trying to do autonomous driving by just driving a car around on the street, many the time and use cases that the car encounters are just the normal use cases over and over again. But ultimately, for the training, what the models really want are all of the various edge cases. So, again, different environmental conditions, rain, snow, construction sites, pedestrians, opposing traffic. And in the simulation environment, one, you want the simulation to be as accurate as possible, so lots of detail and driving high performance compute, but also then the capability to introduce a higher variety and frequency of edge case that then happens in the real world to help initiate the model. So you get additional business and engineering product design benefit by being able to do that type of simulation online as opposed to in the physical world. And of course, the same thing I mentioned before, crash testing. Obviously, it's many times more cost saving and time productive to be able to do crash simulations in the computer and then just correlate that with a limited number of actual crashes, as opposed to needing to build prototypes and then destroy them in the testing, of course. And then finally, traditional engineering technique, not necessarily new at the moment or emerging around digital twin, but the real issue around digital twin, not just the saving of solid model and engineering calculations and so on, but being able to correlate that with real world performance, not only for products, but also manufacturing processes, manufacturing facilities, the human interaction components of it, and more importantly, the behavior of the product in the real life world, especially with smart or intelligent products that can provide consistent data streams back, whether that's connected vehicles, autonomous driving, as I mentioned, or so on. These large real-time data flows now present a lot of challenges and constraints for traditional on-prem infrastructures at many customers and companies, and being able to ramp up, as I said, that in the cloud to be able to use the advanced technologies for anomaly detection, machine learning, and advanced analytics allow folks to be able to do a closed loop analysis of their digital twin and manufacturing 4.0 initiatives much more easily and quickly than they could have with traditional technologies. So those are some examples of where high performance compute and cloud more specifically are helping product development teams.
Thanks, Rick. Digital twin, autonomous driving, there's so many different examples of where high performance computing can make an impact. And I also wanted to share some performance metrics from our data to indicate that connection between the use of a cloud infrastructure and time to market, and also the number of complete physical prototypes, which you touched on as well. So manufacturers deploying their engineering solutions in a public cloud environment are seeing greater annual improvements in manufacturing cycle time and production downtime. This shows that HPC is helping them quickly run their calculations, compile and analyze product and material data, and identify patterns in product behavior so they can make adjustments and optimize their design performance. These numbers validate the productivity and manufacturability benefits of the public cloud. And additionally, those using public cloud are seeing a decrease in the number of physical prototypes they need to create per year. With public cloud and faster simulation and virtual prototyping solutions, there's less need to generate physical prototypes during testing, which reduces overall operating costs and waste. Overall, there are great numbers here for the benefits of public cloud on time to market, but that's just one area where cloud infrastructure gives engineering teams an advantage. Migrating your engineering solution suite to the cloud can also impact collaboration and change management processes. The top two reasons our respondents cite wanting to move to the cloud are to facilitate remote-based collaboration and to share and manage documents and streamline workflows more easily. Our data reveals that public cloud users are indeed more likely to do both of these than hybrid or on-premise users. Public cloud users are ahead in their adoption of formal processes for change management. Integration is a top challenge that we see for organizations undergoing digital transformation, and a cloud-based infrastructure can bring together all engineering solutions on a single platform. With a unified platform, changes can easily be communicated across all engineering applications, and it also minimizes the effort to deploy different technologies in different environments, ultimately enabling faster time to implementation for engineering solutions and greater accessibility. Public cloud users are also more likely to standardize their processes to request changes. So not only are they working with HPC in the testing phases to improve quality, but they're also streamlining workflows wherever quality issues are identified in later stages and communicating those changes effectively back to the design teams. This helps to optimize the engineering change order process so the right information is communicated back to the engineering folks, and then they can make those updates and reduce the need for more changes going forward. The communication channels and integration between systems in the cloud is what makes all of this possible. The last two data points around the processes for creating the manufacturing bill of materials and the engineering bill of materials, as well as the view of system integrators, demonstrate the wider impact of a cloud environment on the communication channels between different teams. Public cloud users are more likely to see reductions in time to decision, development time, and engineering change orders year over year, as you can see from the data here. I mentioned engineering change orders previously, as well as the time benefits, but one thing we haven't really touched on is the time to decision piece and how the cloud helps with that. Having a single cloud-based platform is important for engineering solutions so that manufacturing and engineering leaders only need to go to one place for all the information required to make decisions about production schedules, new product statuses, and any aspects of design and manufacturing. These metrics demonstrate how greater collaboration in the cloud and having a single platform can influence speed to market and time to decision, as well as overall quality and cost, which we'll talk about in the next section. But first, I want to hand the mic over to Rick to ask him to elaborate on how organizations can promote greater collaboration with a connected platform in the cloud for all their enterprise applications.
Yes, Sarah, as you alluded to, engineering organizations don't exist necessarily on an island or in a vacuum, but rather they work within the rest of the complexity of their business organization. So the need to speed up the engineering process is a microcosm to some degree of the need to speed up the entire business process, or especially the interaction with the engineering, product development, manufacturing, and field service organizations, expanded product design with the rest of the whole organization. So, for example, getting more access to data that might otherwise be in silos in an organization around customer requirements or product test results or competitive analysis is important to the engineering group. Likewise, the same thing with constraints that might exist around production capacity, around supplier capacity, around material and supply chain availability, especially in all the challenges currently going on in COVID. And also downstream from customer service, customer experience, field service, manufacturability, and maintenance standpoint as well. So how does that relate to the cloud? Well, the fact is that many of these customer organizations, that the other disciplines and other functions in the company are also moving off to the cloud. And in fact, in Oracle's case, we offer a broad suite of applications that many customers are using for finance, procurement, sales, marketing, service, and so on. Whether it's Oracle's cloud or another cloud, interacting with, getting access to, and interfacing with other parts of the business who have their information in the cloud is in most cases just a lot easier than it was with a bunch of disparate technologies in traditional on-prem environments. And once that's done, in fact, in Oracle's case, as I alluded to, the best of the situation is where most of your business applications are all able to interact with each other, where you can get ready access to that data. When you pull that together, one, it saves lots of time. Some engineering studies have shown that engineers spend 30-40% of their time on non-engineering tasks just trying to get to data in the rest of the organization. And not only is the acquisition of that data, but then being able to easily understand it and analyze it. So that's, of course, traditionally what Oracle was very known for in our database history, but also now in the cloud across the suite of applications that we have, we've got a number of advanced cloud-based analytic tools that make it very easy for end users or folks in the engineering organization to do advanced anomaly detection, not only traditional engineering calculation, but just management level summary analysis across lots of business data that ultimately play into decisions that need to be made around bringing products to the market, about doing enhancements, design revisions, and maximizing the customer's experience.
Thanks, Rick. Moving into our last section on quality and cost, the main takeaway here is that while the cloud has a lot of benefits for the organization, most of them boil down to cost, quality, and time. In our survey, we asked respondents to estimate the percent of their products that meet launch dates, the percent that meet cost targets, the percent that meet quality targets, and the percent that meet revenue targets. So 4 key areas that are often evaluated in manufacturing and engineering. And you'll see by the numbers here that public cloud users are more likely than hybrid and on-premise users to have products that meet their targets in all of these areas. The advantages we've been talking about around manufacturing cycle time, development time, and time to decision all impact the percent of products that make it out the door on schedule. Cost targets have a few angles that we can approach these findings from. The first one being greater collaboration capabilities that are helping to reduce time and resources during the design and production processes, which trickles down to reductions in operating costs. The second one is that the ability to run more comprehensive simulations during testing helps to improve quality, and fewer quality issues farther along in production processes ultimately reduces the need to keep scrapping products that have already been created and go back to the drawing board. The third and final angle is the overall cost savings from leveraging a cloud infrastructure, which comes from the storage flexibility and scalability of a cloud environment. I've been mentioning quality a lot, but here we have some hard data around the quality benefits of cloud-based digital design. With greater quality, you can ensure customer satisfaction and maintain your overall brand image if you're not having to do recalls frequently. And then the revenue targets, showing that higher quality, lower cost products are more desirable in the market. These findings validate the impact the cloud can have on the operational side of product design. Rick, I'd like to pose one last question to you. How do the performance improvements you've witnessed from your clients after a move to the cloud align with what we're seeing at Aberdeen?
Yeah, good final question. We talked a lot about cloud and the benefits of data analysis. We'd be remiss if we didn't use some real live data just as a testimonial in this presentation itself. So a good case in point, one of our early Oracle Cloud high performance compute engineering adapters was Altair, one of the leading engineering service providers here in North America and around the world. They're both for us a direct customer using our cloud in the services that they provide for engineering analysis, and also a system integration partner, so helping ultimately other end users that may consume our services directly, either on a consultative basis or with some of their engineering software and tools as well. In Altair's case, they saw when they moved to Oracle Cloud about a 25% price performance increase over other cloud providers that they were using. And of course, that's relative to an already optimized environment. So savings would have been bigger than that, maybe of a couple magnitudes over time from more of a traditional on-prem infrastructure if you went back further enough in time. And also the ability to provide complex engineering analysis, for this case, vehicle simulation, sort of in less than 12 hours. So things that used to take multiple days or multiple weeks in some cases to run for queue time, and or trying to iterate a model multiple times, they can now get to the point where they can do that all instantly in 1 or 2 runs and do it all on demand. So great savings for them and similar savings for some of our other end use customers. For folks who might be interested in more of our customer stories or more information specifically on our Oracle Cloud Infrastructure compute services for digital product design, and the most up-to-date stories as well, you can always go to www.oracle.com and then follow that up with some of the slash notation that I've listed here. So other examples, Red Bull Racing, the Formula One Driver Championship this year heavily uses engineering services and cloud computing services from Oracle. Customers will find more and other customer information, including some of them listed here. For example, Thermo Fisher in the medical device industry, a number of automotive customers underneath slash high performance compute. Ingersoll Rand, who moved some of their engineering applications to the cloud as well underneath our data lakehouse area. And Western Digital, a customer that's a great poster story for complex industries underneath slash integration and slash business analytics. So lots of great customer testimonials out there.
Great. Well, that's all the awesome content we have to share today, but we want to leave you all with a few final thoughts. So the first is that engineering teams are turning to the cloud to support their digital transformation initiatives, seeking greater productivity, collaboration, and cost savings. Rick and I both talked a lot about how having a cloud-based infrastructure can impact all these areas. Cloud-based digital design impacts people as well as processes. So not only does it speed up processes and improves quality, but it just generally makes engineers, manufacturers, and leaders' lives easier when everything's on the same platform and communication is cleaner and faster. Quality and cost implications of deploying engineering solutions in the cloud help engineering teams improve brand image and operating margins. The brand image piece tying back to quality and operating margins tying back to cost improvements associated with the cloud. And lastly, operational advantages of cloud infrastructure in engineering promote an efficient, agile development approach and set the groundwork for growth. A lot of the benefits we talked about today demonstrate the foundation that the cloud can help organizations build as they continue their digital transformation journeys and continue to adapt to changes in demand, economic uncertainty, supply chain issues, all of the above. I'm sure Rick and I could talk at length about the importance of the cloud for agility, but the operational benefits we walked through today should give a good indication of the direct impact the cloud can have on helping your organization thrive in the unpredictable world we're all living in. Thank you for tuning in. If you have any more questions around Aberdeen's research or around Oracle and their services and win stories, feel free to reach out to Rick or I with our contact information here.
With that, we'll conclude our webinar for today. I want to thank our speakers for sharing their research, insights, and recommendations with us. Special thanks to Oracle for making this webinar possible. We hope you enjoyed the session. Thank you for attending.